I'm here on the crystal white sands of Pensacola Beach in the Gulf Coast of Florida, and there's a lot of uncertainty around these parts about what effect the oil could have on the beaches, how long it'll be around for, and what can be done to clean it up. But as I've discovered, two Florida State University researchers believe that, like the treasure of area folklore, the answer could be buried in the sand itself. Florida State University graduate students dig in the sand looking for gold. Black gold, that is. These students work with Joel Kostka and Marcus Huddle, two Florida State University researchers interested in nature's ability to handle the oil washing up on Gulf Coast beaches.
So what we're going to do is we're going to dig a trench here to get an idea on the distribution of the oil, how deep it is, how thick this layer is that is contaminated.
These sands serve as a natural filter for the coastal waters. Tiny microbes in the sand clean up any toxic substances that may find their way into the ocean, and that includes oil.
Oil is a natural biological product. It enters the marine environment naturally. There are many natural oil seeps that oil comes out of, and so microorganisms have adapted or evolved to use that oil as food. And so oil degradation is actually also a natural process. We just want to understand what controls it and how we can encourage that process to clean up this pollution.
This light brown color, that indicates that we have oil components in these layers.
The speed of degradation, they say, is directly proportional to the amount of oxygen available to the microbes. The deeper the oil sinks into the sands, the longer it takes to break down.
10, 20, 30, looks like 30 to 50 centimeters is where we see the oil layer.
And this can be a major problem for the ecosystem.
When there's oxygen present, the oil would be broken down in days to months, whereas without oxygen, the oil can persist in beach ecosystems for decades. Put that big block down and I'll put it on top of there.
The teams take core samples of the sands, along with measurements of oil and oxygen availability. They then take these samples back to the lab and get down to the nitty-gritty.
Hello, Ohm.
Joel Kostka's research focuses on the microbes themselves. He wants to understand which microbes are at work in both the oxygen-rich and oxygen-deprived levels of sands, and how effective each is at breaking down the oil.
And what we found is just like I said. Basically, under anaerobic conditions, the oil tends to last much longer, weeks to months or even longer.
Meanwhile, Marcus Huddle seeks to understand the logistics of the filtering process.
How does the oil get in there? How deep does it go? How fast? We measure oxygen penetration in these cores, how much oxygen is available in the different layers, how fast water can penetrate, how much water is penetrating. This is a shell covered with tar. How long will it stay there? At what point can we tell our people here in Florida, well, it's safe to go to the beaches. It's safe to dig a hole in the sand. It's safe to go swimming.
In harnessing the power of nature, these two Florida State University researchers may ultimately find the solution that restores these beaches to the natural beauty so many have come to enjoy. For Florida State Headlines, I'm Matt Roush.